Hi, this is Ms. Robinson going over problem number 7 from the honors test review on limits. All right, so we've got what we see here as a rational function with two asymptotes, and it also says we have a horizontal asymptote at y equals 0. So it's hard to see, but that means there is an asymptote here on our x-axis. So what we need to do when we state limits is pay attention to the behavior of the function as our x values are approaching these asymptotes, specifically the asymptotes here at -3 and the vertical asymptote here at 1. So notice what we're going to do is talk about, with these limits, that the graph is going left forever here, and it's going down forever here, and it's going up forever here, and down forever here, and here, up forever, and here, right forever, towards, well, we'll talk about that, but towards 0. So this is going to be to help you write your limits, but you will not have this on the test, meaning you'll have to state all of your limits by having this as an understanding of what it is you're trying to find. So what this means is we have to think, what is the function doing as x is approaching -3 from the left? So that little negative means from the left, whereas here, this -3 plus up here means from the right. So as x approaches -3, so on our graph, where is -3? It's right here. So as we're approaching -3 on the left side of -3, well, the left side of -3 is over here. So that means as we're approaching -3 on the left side of -3, what happens to our function? If you follow it down, it's actually going down forever as we approach -3 from the left. Well, down forever means our graph is approaching -infinity. So remember, f of x are your output, or your y values. That means your graph. So when I say the graph is going down forever, that means our f of x is approaching -infinity. Now we need to evaluate what is happening as x is approaching -3 on the right side. So that means, don't worry about all this stuff going on here, but as we get closer to -3 on the right side of -3, we can see that our function is going up forever. And since it is going up forever, it is approaching a y value of positive infinity. So just, if you get confused, remember, think f of x is your y's, okay? So next, we're going to evaluate what the function is doing as our x values approach +1, but from the left side. So here's +1. As we come in from the left side and approach 1, what is our function doing? It is going down forever. This right here, as we approach 1 from the left side, the graph is going down forever, meaning it's approaching -infinity. And it may even be helpful here for you to put like -infinity, -infinity, and up here, positive infinity, and positive infinity, but don't put it here. That will probably help you out as you are filling these in. Next, we want to evaluate what happens to our function as our x value approaches 1 from the right side, positive meaning the right side. So if we come over here, and here's our x value of 1, as we approach 1 from the right side, what's happening to our function? It's approaching infinity. It's going up forever. Next, we have to evaluate what happens as our x value approaches -infinity. So we have to think about this differently. We're still looking at our y values, but we are now going to the left forever. So coming here, as we go left forever, approaching -infinity, what's happening to our function? Well, as you can see, there's a horizontal asymptote here on our x-axis, and it's preventing our function, as the graph is going left forever and actually right forever, it's preventing it from going up or even touching 0 or passing 0 to go to positives. So we would state that as our x approaches -infinity, our y values are approaching a limit of 0. So we fill in 0. It's approaching this horizontal asymptote at y equals 0. It approaches 0, but it never hits 0. Now, let's evaluate as x approaches positive infinity. So as x approaches positive infinity, we have to think, well, as my x values go towards positive infinity, what is my function itself doing? This function here it's getting closer and closer and closer to 0, but not touching it. It's just above the x-axis rather than below like it is on the left side. But we still say that as x approaches positive infinity, our function is approaching 0. So hopefully you're understanding, excuse me, relating this back to in behavior. And what's just different now is we're looking at the behavior not only as it approaches positive and negative infinity, but at different parts in the graph because of these asymptotes. But next we have to be able to write limits. So this is a tool to be able to help you, but let me show you now how you have to write the limits. So we have 1, 2, 3, 4, 5, 6 limits that we have to write, which means this test question is going to be a 6-point test question, okay? So what we state is the limit, and then underneath, as x approaches, and we'll start with the first one, -3 from the left, the limit equals negative infinity. And that's how we write a limit. The limit, and then underneath it, it's almost like a subscript written smaller. The limit as x approaches -3 from the left is negative infinity. So again, as we approach -3 from the left, our function is approaching negative infinity. So that's the limit of our graph as it approaches that value. So we have 6 of these we have to write. So I'm going to put limit, 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 limit. So we're basically going to take all of these and put them underneath. Now you're not going to have this tomorrow on your test, so what you're going to need to pay attention to is understanding that you should be able to count how many limits you write based on the graph. So for every vertical asymptote, you have to do 1 for each side, so that makes 1, 2, and you have to do 1 for each side of this vertical, so 1, 2. So that's a total of 4. And then you also have to do it as it approaches negative infinity and positive infinity, so that makes 2 more, so 6. So 1 for each side here, and 1 for each side of your vertical asymptote. So you have 6 limits to write for the test. So next we would just say, okay, we've done as x approaches -3 from the left. We need to write as x approaches -3 from the right. We need to write it as x approaches +1 from the left side. And we need to write a limit for the function as x approaches +1 but from the right side. So we'll put that plus. Then we need to write it as it approaches negative infinity and as x approaches positive infinity. And you don't have to put the positive there. Alright, so next it's just a matter of looking at what our function does. So this is going to help us. These are the values we need to plug in here for our limits, for the value of our limit. But I'm going to do it as if we didn't have this list, okay? So we've already done the limit as x approaches -3 from the left was negative infinity. As x approaches -3 from the right, it approaches positive infinity. The limit as x approaches 1 from the left is negative infinity. The limit as x approaches 1 from the right is positive infinity. The limit as x approaches negative infinity is 0. And the limit as x approaches positive infinity is 0. And so these are the 6 we'll be looking for on your test on the limit problem. Good luck.